This is SpaceTime, Series 25, Episode 15, for broadcast on the 4th of February 2022. Coming up on SpaceTime, counting down to a crash on the Moon, the James Webb Space Telescope reaches its final destination, and the earliest known report of the mysterious phenomenon known as ball lightning in England. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A 4-tonne Falcon 9 upper stage booster will crash into the Moon on March the 4th, hitting the lunar surface at over 9,000 kilometres per hour. The booster was part of a rocket launched 7 years ago, carrying NASA's Deep Space Climate Observatory Discover spacecraft into orbit at the Lagrangian L-2 position, a sort of stable gravitational well, where the gravitational pull between the Sun and the Earth balance each other out. Since that 2015 mission, the upper stage Falcon 9 booster has been in a chaotic orbit. That orbit saw it pass close to the Moon on January the 5th, and this close encounter altered the booster's orbit, placing it on a course that will see it collide with the Moon on March the 4th, slamming into the lunar far side somewhere around the Hertzsprung crater. While the impact won't be visible from Earth, NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-2 spacecraft should be able to image any impact crater created by the collision. Of course, spacecraft have crashed onto the Moon before. After all, people have been filling space with space junk for years. And scientists have even crashed some spacecraft onto the lunar surface deliberately. During the Apollo era, a Saturn launch vehicle booster was deliberately crashed onto the Moon to test seismic equipment left by the Apollo astronauts. Those seismic measurements were used to help characterize the lunar interior. And in 2009, NASA sent a booster stage hurtling onto the lunar South Pole in order to look for signs of water in the impact ejector. This is SpaceTime. Still to come, the James Webb Space Telescope reaches its final destination, and the earliest known report of a phenomenon known as ball lightning in England. All that and more still to come on SpaceTime. NASA's James Webb Space Telescope has finally arrived at its new home, the Lagrangian L-2 position, a gravitational well 1.5 million kilometres away on the opposite side of the Earth from the Sun. The final 5-minute orbital insertion burned by its onboard thrusters placed the $10 billion observatory into a halo orbit around L-2. Webb's orbit will allow it to get a wide view of the cosmos at any given moment, as well as an opportunity for the telescope's optics and scientific instruments to cool down enough to function and perform optimal science. The James Webb Space Telescope was launched on December the 25th last year aboard an Ariane 5 rocket from the European Space Agency's Kourou spaceport in French Guiana. Mission managers have used as little propellant as possible for course corrections during the journey so as to leave as much fuel as possible on board for ordinary station-keeping operations over its lifetime. Meanwhile, the telescope's continuing the delicate 3-month-long process of aligning its optics. James Webb's primary mirror is a 6.5-metre diameter gold-coated beryllium reflector composed of 18 hexagonal segments. The telescope will provide improved infrared resolution and sensitivity over Hubble, viewing objects 100 times fainter. It'll look back through space-time more than 13.5 billion years, allowing astronomers to see some of the oldest and most distant objects in the universe, including the first stars to shine, the birth of the earliest galaxies, and the atmospheres of distant worlds which could support life. The James Webb Space Telescope is a feature in this month's issue of Australian Sky and Telescope magazine. Joining us now with the details is the magazine's editor, Jonathan Nally.
G'day, Stuart. Our cover story this month in Australian Sky and Telescope is all about the next biggest amazing thing, the James Webb Space Telescope, or JWST, or people just call it the Webb. It's the next generation of orbital observatory. It's named after James Webb, who was an early head of NASA. And you'll sometimes hear it described as the successor to the Hubble Space Telescope. In some ways it is, newer and bigger than Hubble, of course, but in other ways it isn't. So size is really important when it comes to telescopes, particularly the size of the main mirror. It really does matter with telescopes because the more light-gathering power you have, the fainter you can see. And the fainter you can see means the further away you can see, because things that are further away are fainter. So Hubble has a mirror that's 2.4 metres in diameter. The James Webb Space Telescope's mirror will be 6.5 metres in diameter. So, it's much, much bigger, much bigger. Now, whereas Hubble was optimised to do its thing with normal optical wavelengths, plus a little bit of ultraviolet and infrared wavelengths as well, Webb is mostly optimised to do infrared. Now, infrared means it will pick up the light of very, very dim or very, very distant objects. And what we're talking about here primarily, although it will do other things as well, but primarily it's intended to look back through time, through the universe, to the emergence of the very first stars and galaxies. Now, Hubble's taken us quite a long way back on that journey, but the James Webb Space Telescope will take us even further. The thing is that we've all heard of redshift. So what's happening is that the wavelengths of light that were emitted by the first stars and galaxies way back then were emitted at normal wavelengths, if you want to call it that. By the time they've reached us, they've all gone very infrared. So you need a telescope that is optimised for that. So infrared, you can think of it as just being heat. So in the magazine, we take a look at the amazing technologies that will make this telescope work. From its gold-covered mirrors, would you believe it or not? The mirrors are not made of glass, they're made of metal, and they're covered in gold because it's really good for reflecting this kind of these particular wavelengths.
That almost goes back to the times of the very first telescopes that used metals instead of glass mirrors. I think the Great Melbourne Telescope was like that, wasn't it?
Yeah, it was called a speculum. Yeah, it was made of metal. The particular metal they're making this one of, which they have made this one, is very low expansion. What that means is that as it heats and cools, which actually shouldn't do much of, but as it does, some materials will expand and contract when they're heated or cooled. This particular kind of metal is meant to keep its shape. So you really want to keep the shape of a mirror as precise as possible. So you don't want things to be expanding or cooling with changes in temperature. And to keep it at the right temperature, it's going to have this amazing stack of ultra-thin heat shields that will protect it from the heat of the sun. With infrared being basically heat, you need to remove any sources of heat from the telescope and its cameras and everything itself, so those sources of heat don't overwhelm the very faint infrared wavelengths coming in from the things that you're supposed to be looking at. So it's going to be in deep freeze and kept as cold as possible in order to do its job. So really amazing machine.
Is that why it's located in the Lagrangian L-2 position on the opposite side of the Earth to the Sun?
Yeah, so with the Hubble telescope, it's just orbiting the Earth, goes around in fairly low orbit, about 500 k's or something like that, approximately. And they did that with Hubble because they wanted to be able to get up to it with the space shuttle and do these periodic upgrades, and as it turned out in the end, do periodic repairs as well. So that was brilliant for all that, and Hubble worked well because, as I said, it was mainly operating at what we call optical wavelengths, the sort of normal light wavelengths, with a little bit of infrared, a little bit of ultraviolet. But because James Webb Space Telescope needs to, looking at the infrared part of the spectrum, it needs to get away from all potential sources of heat, including the Earth itself. So they're getting it away from the heat of the Earth. The Earth just reflects the heat from the sunlight and everything. But yeah, they just want to get it as far away as they need to from the Earth so that Earth's heat doesn't contaminate the observations from the telescope, but not so far away that it takes a long time to get signals back and forth, that kind of thing. It is so far away that it's on its own. There won't be any repair missions or upgrade missions or anything like that. So once it gets out there, it'll be doing its job for hopefully decades. Just on its own. But that is the reason they got it away from Earth, is to get it away from heat, basically. It's not purely NASA, of course. There are other people involved, other space agencies involved as well. So it's an international mission, and just like Hubble, once it's up there, it will operate as an international observatory, as so many different scientific facilities all around the world, not just telescopes, but all sorts of other labs and things. These missions are so important and sort of one-off that they don't operate them as national facilities and only people from that country can can use it. So the way these sort of telescopes run is that once they're up and going, astronomers apply for their little slice of time to use the telescope, and it's always oversubscribed. They always have 3 or 4 times as many applications as they can handle. So a special committee sifts through all the applications and decides which ones get the nod, and people from anywhere around the world, scientists from anywhere around the world, basically can use it. There's usually a little bit in the initial stage. Is usually a little bit of time set aside for the hard-working scientists who have been working on this telescope for 20 years or so. So they're the ones who, they plus all the engineers and technicians and everyone.
Yeah, people don't realise that. They think, oh, things gone up there, it's working now, that's great. Next, it doesn't work like that. The people who built the thing and developed it and designed it and were commissioned to build it, this is a career, this is their entire career.
It certainly can be, yeah. It could be their life's work. So generally there's a period of grace where those people get first crack at it, and they can do their observations first as a bit of a reward, if you like, and they get to sift through the data first and publish their scientific papers, and then all that data becomes freely available to anybody after a certain period, which is usually about 6 months or 12 months or something. But after that initial period, anyone will be able to apply for time, and based on merit, their applications might be accepted or not. But anyway, it's got a decades-long lifetime, so there should be plenty of time for everyone to have a go.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And this is Space Time. Still to come, the earliest known report of the phenomenon known as ball lightning in England, and SpaceX's CRS-24 Dragon cargo ship successfully returns to Earth, splashing down in the Gulf of Mexico. All that and more still to come on Space Time. Researchers have discovered what appears to be the earliest known English record of a still controversial and extremely rare weather phenomenon known as ball lightning. Ball lightning, which is usually associated with thunderstorms, is unexplained and has been described as a bright spherical object, on average around 25 centimetres across, but sometimes up to several metres in diameter. Emeritus Professor Physicist Brian Tanner and historian Professor Giles Gasper, both from Durham University, discovered a reference to an alleged ball lightning event while exploring a medieval text written some 750 years ago. The account by the 12th century Benedictine monk Gervase of Christ Church Cathedral Priory in Canterbury predates the previous earliest known description of ball lightning recorded in England by nearly 450 years. The findings have been published in the Royal Meteorological Society's journal Weather. In his chronicle, composed around the year 1200, Gervase says that a marvellous sign descended near London on the 7th of June 1195. He goes on to describe a dense and dark cloud emitting a white substance which grew into a spherical shape under the cloud and from which a fiery globe fell towards the river. The Durham researchers then compared the text in Gervase's chronicle with historical and modern reports of ball lightning. Tanner says Gervase's description of a white substance coming out of a dark cloud, falling as a spinning fiery sphere, and then having some horizontal motion is very similar to historic and contemporary descriptions of ball lightning. Prior to this account, the earliest report of ball lightning from England was during a great thunderstorm in Devon in October 1638. The thing is, medieval writings rarely survive in the author's original version, and Gervase's chronicle and other works now only exist in 3 manuscripts, one in the British Library and the other 2 at the University of Cambridge. The text, which is in Latin, was edited by Bishop William Stubbs in 1879, and there is no translation into English. The researchers looked at Gervase's credibility as a writer and as a witness, having previously examined his records of eclipses and a description of the splitting of an image of the crescent moon. The study's co-author Gasper says that given that Gervais appears to be a reliable reporter, he and Tanner believe that his description of the fiery globe of the Thames on June the 7th was the first fully convincing account of ball lightning anywhere. As to what ball lightning really is, if it exists at all in fact, well, the mystery there remains. Emeritus Professor Robert Crompton from the Australian National University, who's collected dozens of eyewitness accounts of ball lightning over many decades, says two main theories have been put forward to explain the phenomena. One hypothesis, based on the physics of electrical discharges, suggests that lightning strikes and travels slowly through conductive channels in the ground, generating a corresponding electric field in the air as it moves, and the ball lightning is formed from electricity discharging in this field. The other idea, which is more chemical and geological, involves lightning hitting a substance containing a 2-to-1 ratio of carbon and silica. The extreme heat of the lightning then converts these chemicals into carbon dioxide and nanoparticles of silicon, which puff out of the surface in the shape of a ball. The ball shimmers as the silicon oxidizes in the air, generating heat and light. Crompton says the second idea was given a boost by an experiment carried out by French scientists, which recreated silicon nanoparticles in the laboratory using electricity. However, none of this would explain reports of ball lightning passing through walls and entering buildings. Nor does it explain a well-documented case in suburban Canberra, where Crompton says a man was standing next to his garage door when lightning struck nearby. Shortly afterwards, he saw an orange-yellow ball of rotating light slowly floating towards him. It entered his metal garage through the open door and bounced twice on a board of wood before disappearing in a loud bang like a rifle shot. Crompton says the object left marks on the board which were later analysed by Australian Federal Police Forensics. They found the marks to be titanium oxide, a heavy metal used in some types of paints. But apparently there wasn't paint splash or spill marks as you'd normally expect to find in a garage. Crompton thinks the ball lightning was an ionized electrical discharge, and in this case the lightning struck a painted pole with some of the paint being incorporated into the ball lightning. Another hypothesis involves rapidly charging magnetic fields caused by thunderstorms. Apparently, if these magnetic fields focused on the visual cortex of the human brain, they could induce eddies through transcranial magnetic stimulation, which would cause people to think they're seeing lights that look like disks and lines. And as the field moves within the cortex, the subject sees the lights move too. But this too is just a hypothesis. This is SpaceTime. Still to come. SpaceX's Dragon CRS-24 cargo ship successfully returns to Earth, and later in the science report, could the popular social media app TikTok be weeding its way into kids' brains? All that and more still to come on SpaceTime. SpaceX's CRS-24 Dragon cargo ship has successfully returned to Earth, splashing down in the Gulf of Mexico just off the Florida coast. The return had been delayed by 2 days due to bad weather at the Splashdown zone. The spacecraft brought with it some 2.3 tons of returned experiments and space station hardware. The mission had launched 34 days earlier from Space Launch Complex 39A at the Kennedy Space Center in Florida aboard a Falcon 9 rocket. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that 75% of COVID-19 patients who survived after being admitted to an intensive care unit are still experiencing physical symptoms a year later. The findings, reported in the Journal of the American Medical Association, are based on follow-up studies with 250 Dutch COVID-19 survivors a year after their ICU stay. 3/4 of these patients reported ongoing physical symptoms, including fatigue and impaired fitness. 1 in 4 reported mental symptoms such as anxiety, and 1 in 6 reported cognitive issues. More than 5.6 million people have now been killed by the COVID-19 coronavirus since it first spread out of Wuhan, China. However, the World Health Organization believes the true death toll is likely to be double that amount, with almost 360 million confirmed cases globally. A new study has worked out why women are more likely to give birth at night. Primates, including humans, tend to have their babies at night, but exactly why has always been unclear. Now, a report in the journal Biology Letters claims the key could be body temperature. Scientists followed a group of wild vervet monkeys that were fitted with devices to measure their body temperature, and they found that the monkeys' body temperatures dropped when they were about to give birth. The authors say that by giving birth at night when it's cooler, it may take less energy to drop their body temperature compared to giving birth during the heat of the day. The authors say their findings offer fresh insights into the evolution of primate birth timing and may also provide an evolutionary explanation for some of the health risks associated with human birth. A new study warns that the popular social media app TikTok may be weeding its way into kids' brains. A report in the journal Drug and Alcohol Review suggests that cannabis-based content on TikTok are prevalent and may influence the perceptions of its use. The study's authors searched through the social media platform for hashtags based around cannabis use and say that over half the videos they found portrayed the drug in a positive light, and none of them were age-restricted. As more than a third of the platform's users are under 14 years of age, and previous research has demonstrated that exposure to cannabis-related content can be negatively influential in adolescents, the researchers suggest it may be important for more effective age restrictions and regulations to be introduced to social media sites and apps. Earlier studies show that TikTok can spy on and copy other files on devices it's downloaded into, and so can be used to collect information on your children. There's a new warning out about the dangers of so-called anti-5G radiation jewelry. A study shows that rather than provide protection, these items are actually emitting harmful ionizing radiation. The warnings by the Dutch Authority for Nuclear Safety and Radiation Protection covers energy armor sleeping masks, bracelets and necklaces. A bracelet for young kids branded Magnitex Wellness was also found to emit radiation. 5G networks have been subjected to numerous conspiracy theories, including claims they're responsible for the COVID-19 pandemic. But the World Health Organization says 5G mobile networks use non-ionizing radio waves that don't damage DNA and are fundamentally no different to existing 3G and 4G signals. Tim Mendham from Australian Skeptics says so-called anti-5G devices don't work and in this case are actually harmful.
It keeps coming. The trouble is these things keep popping up a lot. Little products like medallions, bracelets, necklaces, masks in this particular case, all sorts of things which are designed to protect you against radiation. And in this case, 5G radiation. In previous incarnations, it's been microwave radiation. Otherwise, it's been in UV radiation, all sorts of things. And it's almost the same product, which is just re-stamped for a new market. And obviously, anti-5G is a bit of a market at the moment, equally unfounded as some of the others, but never mind. The trouble is, the irony is that these products actually release radiation, ionizing radiation too, which is the dangerous sort of radiation, as opposed to non-ionizing radiation, which is what the telephone networks are based around. So even by protecting yourself against 5G, you're actually making things worse for yourself. And the fact they've got a baby version or a children's version called a Magnetics Wellness thing, which is also radioactive, is sort of a great problem. The curious thing about these things is that all these products are out there protecting you against radiation have no way of actually doing it. Little stickers you can put on yourself as if a sticker is going to protect you. Trouser legs or things around your arms or something like that. Or in this case, jewelry, medallions and things are supposed to protect you against radiation. No indication of how, or how a small object is going to protect your whole body from radiation. So it's pseudoscience. It's dangerous science. It's not even science, actually. It's dangerous products that you have to pay a lot of money for. So on every count, these things should be disappeared from the marketplace. In fact, some of this research that was being done in Holland, the authorities there have told all the resellers that it's prohibited. You take it off the shelves or the online shelves immediately, and you must go and tell your customers that the product you just sold them is actually harmful. So they're taking it very seriously. So it's interesting to see how it works out. But the product itself just keeps popping up again and again. Very similar, medallions and necklaces and bracelets and this sort of stuff. They're just targeting a different particular demon that is the threat of the day.
The threat du jour.
the threat du jour, which is 5G at the moment. It'll be something else in a couple of years' time.
So what is it that's actually radioactive? Is it the paint? Is it...
No, it's the material it's made of. There is actually some minerals in there.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.